Hi everyone, welcome to today's online event on continuous performance testing. Thank you for joining us. I am Mohammed Topçu, working as a QA engineer at Kloya, and I have my guest Mesut Güneş here. He is an expert in continuous performance testing, and he is the one who will guide us through this critical topic. In this session, we will dive into continuous performance testing and explore how it plays a vital role in maintaining high standards of performance across the software development lifecycle. At the end of the session, we will wrap up with a live Q&A session. If you have any questions while the presentation, you can write down your questions below. Then after the session, we will answer them one by one. So without further ado, please join me in welcoming Mesut Güneş.
Hey, thanks. Thanks for the nice introduction. Let's go to the presentation. Okay, thanks for joining the session. I'll talk about continuous performance testing. So, have you ever faced an issue that is related to performance on the production and simultaneously with the real users? If I can answer it, I can say that yes, I had, and also multiple times. So this is something in common, that you see that there is an issue on the production and you haven't faced those kind of issues in the development phase. So let's dive into the continuous performance testing and understand what's the problem. And the motto will be: performance is a live thing. And this is me. There was an introduction, but my name is Mesut. I'm based in Turkey, and you can find me in the internet with these nicks and IDs. Basically, I'm a principal consultant at Modus Create. Modus Create is a consultancy firm based in the US, and we are consulting mostly companies from all over the world, but mostly in the US and Europe. And uh, let me uh, let me see who you are. Maybe you can add a comment in the comment section or the chat section. Then I can understand the general audience, and then I can maybe prepare the pages for the prepare the speech for the audience. So basically, in this talk, I'll mostly cover the topic around performance testing and also different types of performance testing and how we can apply the performance testing in different uh, for different type of performance testing. And the last section will be more about the benefits of the performance testing. Okay, this is the table of content. As I said, I'll define in the first section what's the performance testing and the concept of the performance testing. And I'll create a connection between continuous performance testing and the performance testing. Then you will get an idea how we can turn performance testing into a continuous performance testing. So it is critical to understand the metrics for performance testing. So I'll talk about the metrics. Without data, we cannot measure anything. So metrics is really important. And the last two sections, mostly how we can apply and how we can get the benefits from the continuous performance testing. Let's talk about what is performance testing first. In a definition, we can explain the performance testing within the real definition of it. So basically, performance testing is a non-functional testing to get an idea about the response time of your system. So performing a performance testing is kind of black box and white box. Both of them are used because if you don't know the internal structure of a system, that you cannot create a good performance testing scripts. So basically, we are testing the non-functionality of a system by using some functionality of the system. So basically, we can define the performance testing within three criteria. The first one is the level of loads that you are applying during the performance testing, and second one is the how we can increase the loads during the performance test. That can be a incremental of the loads, and the third one is the duration, how long we are applying the performance testing. So let's talk about how we can define the performance testing by process, because performance testing is a process. It is very similar to what we are doing in the SDLC as a software development lifecycle. So basically, in the planning phase, we should have gather the requirements from the business side, and then create a plan depends on the requirements. So in this phase, we should collect all the requirements, what should be done during the performance testing, what should be the metrics, what should be the checkpoints, and then so on. So the planning phase is important. In this phase, we are also defining the toolings and monitorings, and also the organization point of the performance testing. That's who should attend the performance testing. It should be also defined in the planning phase. So in the after the planning phase, uh, we should create the test scripts. So defining the test toolings. After that, then you can use what is required for test scripts. So, for example, what kind of scenario should be covered, and then what kind of script you should prepare it. And also, it is also important to create a test data. In this step, you should also create script or some toolings or whatever to create an test data. It should be also prepared in this step. After that, once we have a test script and test data scripts, then we should create a test environment. For most of the cases, we should perform the performance testing on an isolated test environment. So creating a test environment is critical to get the comparable results. And the next phase is starting to executing the test. So which means that we are now executing the performance testing. The executing step is kind of running your test scripts, and then the next step is monitoring the system. So in the planning phase, we define some metrics and some loads, but are we sure that all the loads are coming to the system? So within the help from the monitoring system, we should check that loads are coming to the system and everything is working as expected. And as a final step, after executing and monitoring the system, we should analyze the first output from the performance testing. Um, at this point, we should check that the results are okay, system is behaving as expected, and the response time or other metrics are all of them are okay. So if there's a case that there's a problem and it can be easily solved. So and maybe there should be an optimization on the system as well. So after doing this kind of optimization and fixing, then we should run the performance testing again. So this, as seen in the picture, this is a loop. So you can run or you can repeat these steps as fast as much as you are ensuring that the system is okay or performance testing is okay. Or you can say that, or even you can say that I cannot go further off at this point. So maybe you can go to the planning phase at sometimes later, then you can repeat the steps. And so let's talk about the types of performance testing. And uh, within the test types, we should understand three criteria: the loads, increment of the loads, and the duration. So combination of these three metrics, we can define the performance testing types. For example, the load testing, a basic form of the load test. So which means that whenever I talk to some guys, even maybe those guys are not in the software industry, when I talk to them, they can understand that I am testing as the system at a load level that can be a optimum level. So these guys understand that the load test is the base form of the performance testing, and it depends on the load that is an optimum level. So within the different kind of loads and increment of loads, also duration of loads, we can create different types of loads. So what are those? The first one is the load testing. Then might be spike, stress, and soak, and other types of testing. So let's talk about the load test first. The load test, as I said, is the basic form of the performance testing loads. Whenever I talk to someone, I should definitely talk about the load test. And it is widely known form, as I said, and it should be performed under an optimum load. So the aim of the load test is to understand the production performance of the production. So which means that this is just a simulation of the production under optimum load. And the second one is the load stress test. Within the load test, we're just testing the optimum level. But within the stress test, we need to increase the load test step by step until the system comes to the boundary level of the system. The boundary is in question. How we can find the boundary? Just testing it, because we don't know. If you have any historical data that you know the boundary of the system, it might be an info for you, but it might not be the definite point of the boundaries. So basically, the stress test is testing the boundaries of your system, and it requires more resource than the load test, because we are just going above the optimum loads, and then we are just trying to load more load on your system. And it is good to understand and investigate the boundaries, and also it needs more attention, because you are just playing with the boundaries, which means that you can easily break the system. So maybe one load above, you will break the system, and the system may return 500. Or maybe you can your system maybe scale up, and then new servers join the whole system. So it is good to understand the understand for some promotion days like Black Friday, 11/11, and so on. Yeah. So you can use for kind of promotion preparations. And the second one is the SOC, or it's also called endurance testing. And within the load test, it is optimum load. It is testing the optimum level of your system, and the stress level is just testing your stress or the upper boundary of your system. But the SOC or endurance test is kind of more than your load test, but maybe less than your stress test, but it is a prolonged time, which means that you are doing this kind of performance testing for a long time, not in an hour, maybe it is a days. So we are talking about very long time. And it is good to understand your system under a heavy load for a long time. Maybe we can give an example, the same example for the 11/11 days, or let's say the Black Fridays and so kind of days, which means that in during these promotion days, it continue one day or even maybe week. So during this week, these days, your system should be always up and under a heavy load. So soak test or an endurance test is testing this scenario. And the spike test is also good when you get an suddenly increasing loads or suddenly decreasing also. For example, when you maybe your marketing team created a promotions and then sending a notification for all mobile users, and whenever you click a notification on for the mobile application, it generally sends a lot of requests to your backend server. So which means that you are just simulating a spike on your loads on your system. So this is kind of test that's simulating this kind of behavior on your system. Basically, it is testing when your system suddenly, when the loads on your system suddenly increase and suddenly decrease. So for sudden increase, your system should be scale up, and then uh, while decreasing the load, your system should be recover easily. And the capacity testing is basically testing the maximum user that your system can handle. Within this test, we are sending a lot of user requests on your system and then seeing what is issue on your end. Within the capacity, you are not only sending a user, because each user creation on your database or on your system, it creates a lot of data. So it is good to understand how much user can your system handle. And similarly, for the volume testing is just focusing on the data, on the database part. So whenever your system getting a lot of requests and the data to record and maybe delete and also indexing and a lot of things on your database side, then the volume test is a good candidate for testing this kind of system. Basically, volume testing is testing the performance of your system when your system gets a lot of data. Let's see again all of the performance testing type in one screen, one image. As you can see, within the three criteria, the load and the increase of the load and the duration of the load are the three criteria that we can use to give a name for a specific load testing. So you can see with the let's say blue one, which is the type of the load testing, and you can see that in a green, which is a spike test, because our load is increasing suddenly and also decreasing suddenly. So it is kind of spike test. And within the red one, and also showing the breaking point, it is the stress test, because our load is just increasing gradually at a point that our system can be broken. And the purple one is the the soak test, which is more than a classical load test, but less than a stress test. So, but we are applying the test for a long time. So it is also called soak test. And let's continue with the continuous performance testing. So the continuous performance testing is applying the performance testing on your CI or CD pipeline. Within this implementation, you will get a fast and easy feedback about the performance of your system. So you can imagine that you have a load test, but your load test is running for each commit on your system and then returning a feedback about the last commit on your system on the product. So which means that whenever there is an issue, it will return to a feedback. And this is an explanation for the shift left approaches. So basically, applying continuous performance testing on your system is kind of applying shift left approaches. And also, if you are applying this kind of performance testing that is near to your production line, which means that you are also applying shift right approaches, which means that you are getting more more feedback about your production system. So continuous performance testing is applying and getting all those benefits. And basically, we called different type of performance testing. But what kind of performance testing can be applied to apply for the continuous performance testing? So basically, the load testing is the basic form of the performance testing. So it is easily and adapt to the continuous performance testing because we know how much load should the system should the system to be sent, and also we know the metrics. Maybe it is already defined by business, or it is already taken by the historical data. So for the load test, every time I am assuming that always sending the same amount of user or the load to the system, and then I am expecting that all the load testing should return to the same kind of response. And so load test is very easy to apply your system, but stress or the spike test is hard because spike test is running simulating an quick increase in your data. It is kind of applying hard, but it is still available. Also, stress test is just testing your boundaries, so it can be broke the system. So what we want is just getting a quick and easy feedback about the performance. So it is hard to apply, but when you apply, you still get a lot of benefits from it. And when I talk about the ESOC or the endurance test, it is really hard to apply because it takes long time and it can harm the system. It can be harmful for the system. So let's talk about automated load testing. So load testing is the easy and mostly usable one for the continuous performance testing. So let's talk about how we can automate the load test. So basically for the load test, we need to define the specific level of your load test, and everything should be predefined and everything should be automated, which means that when you are running a performance testing as a manual fashion, all the manual triggers should be automated or scripted. Then we can bind it into the CI/CD pipeline. And the metrics is also important because without metrics we cannot measure the result of the performance testing. So basically we have two kinds of metrics. The first one is the response metrics, and the second one is the volume metrics. Within the response metrics, basically we get a response time for each request, right? And there are some derivation of the response time. For example, if we can also calculate the average response or maybe peak response or the wait time. So these are the response metrics, depends on the response time. And also we have some volume metrics that is related to how much load you used during the test. For example, the concurrent user. Concurrent user is the number of users that your system is currently using. And the maybe RPS or request per second is also very, very important metrics. Even you load your system with a lot of users, maybe your system doesn't get so much request per second. For example, if you are getting 10 requests per second, it might be very low for your system, and maybe you just adapt your system to get 1,000 requests per second. And the throughput is the data within the volume. And let's talk about more on the performance testing. Um, we can talk about the first byte when you send the request. It is called time to first byte, which means that when you send a request to your system, and when your system get the first byte of your system, then it is time to first byte. And similarly, the last byte of the system, also called the TTLB, it is the last byte that your system returning from as a response. And the time between time to first byte and the time to last byte is the response time, basically. But there is also wait time, which means that when you send a request to your system, there is some delay between the time you send the request and time to first byte. So it is also called the wait time. And there's also some value that is calculated based on the response time, which is the average. Average is the mean of the whole response. The median is the one in the middle between max and the minimum value. And peak is the maximum value. Also, there is error rate, the number of error over the number of requests, total requests. And let's talk about more on the volume metrics. The RPS is the one of the most important criteria. Maybe it is more important than the load, because even you load a lot of in the system, but when the RPS is low, then it doesn't mean anything. RPS is the number of requests per second that your system is that the load testing is sending to the system. And the concurrent user is the number of current virtual user. H rate is another value that we need to consider. H rate is the number of virtual users that is adding to your system per second. This is also critical because, as I said, within the capacity testing, your test user is just adding to your system. So your system should handle those kind of loads. And throughput is the data in kilobytes which are sent from the servers. And let's talk about the normal distribution. It is important for the evaluation of your data. When I run the performance testing, at the end of the performance testing, I need to evaluate your system, right? This can be done by two methods. The first is evaluating your historical data, and which means that you saved your historical data and want to consider your current data with your historical data, and the normal distribution taking place. Within the normal distribution, if your data is big enough, then it behaves as a normal distribution. So which means that when I talk about the standard deviation, and within two standard deviation, which means that I am just covering 95% of your data, which means that your current result is similar within the 95 confidence level of your test results. And let's create an hypothesis on this info that every matrix is similar to the historical data within the 95 confidence level. And the second method is just using the static data, which means that you are sending amount, a predefined amount of data to your system, and you are expecting that your system is response of your system should be at a point that you defined earlier. And in this screen, you will see that it is an K6 script, and you are just defining some metrics as a static data. For example, the P95, the percentile of 95, should be less than 350 milliseconds. Similarly, percentile 90 is also should be less than 300 milliseconds. So covering more data requires more time. And similarly, I'm just setting the maximum value should less than 400, and average, median, and mean, also minimum, also defined like this. If all the data that is coming from as a result of your performance testing is less than this, and then you can define that your performance testing is okay. And this is an example how we can use the historical data evaluation with the help of AI. So actually, AI is just using a statistical package. So you can also use this statistical package instead of asking AI. But basically, I'm lazy enough to ask the evaluation to the Gemini 1.0 Pro. So basically, I provided the historical data. You see that the historical data within some data that is average response time, and also some minimum, and also different kind of metrics. And I'm just also sending the current results, and I'm asking AI to check this data if it is in the 95% confidence level of the historical data, and it gives me a result. So my hypothesis is just the current response is within the 95 confidence level, and the alternative one is just the reverse. So the current response is not within the 95 confidence level. So within this examination, the AI just returning that your data is on the last line based on the 95 confidence levels. The current test result can be considered as passing. So just AI evaluate my historical data and historical run. So let's talk about tools and technologies. And I think I have just around 10 minutes, and then I will complete it. So whenever I talk about performance testing, I need to talk about the performance testing toolings. So in the market, we have a lot of paid and open source performance testing toolings. And so what we need for continuous performance testing, we need basically performance testing toolings, databases, reporting toolings. Also, we need maybe comparison toolings like AI, and also maybe some statistical package. Also, we need to have some orchestration toolings. All the things are automated, so and this automation should be handled by orchestration toolings, and also critical one, the monitoring toolings. Whenever I talk about performance testing toolings, maybe you remember those toolings. The open source toolings can be more, but I just put some of them. JMeter is one of the toolings that if you want to use just only the graphical user interface, then you can use JMeter. And the Gatling is an also open source tool. There's also enterprise support by Frontline. It is a Scala based, and it is an how to say the compiled languages, so which have a better performance when I compare to, let's say, Locust. Also, K6 very similar, and then it has very good performance, internal performance. So the K6 is also open source, but there is also enterprise support by Local Impact. And Go is K6 is Go based, but you can write your test cases in a JavaScript. That is very smart way of writing a test case. And Locus is also open source toolings, but it is a Python base. Then its performance is not as good as Gatling or K6. Mm. And there are also some toolings for the commercial one. The Load Runner, maybe one of the well-known one, Blaze Metal, Load UI, and many others. For the automation toolings, as I said, everything is automated, so we need an automation toolings. And the performance testing, continuous performance testing, can be a task in your CI pipeline, and so which means that we need to use one of the CI toolings, and these are mostly well-known automation toolings for the CIs. It is Jenkins, Travis CI, TeamCity, Circle CI, and you can find many others on the market. But basically, you need at least one automation tooling to run your pipeline and run your performance testing toolings. Also, for the orchestration, within the orchestration, I mean that you are handling a lot of scripts, environments, and also collecting some data. Those are kind of small scripts, maybe small toolings, but all the things should be orchestrated. With orchestrated, I mean it should be run easily and then also collect and then also kill the response of those things. So Docker Compose, Kubernetes, Prometheus, these are very well-known toolings on the market. And the monitoring tooling is also important because I need to check the data, that is, if those data are coming my system or not. So New Relics, Dynatrace, App Dynamics, and others. You can use any of them. Maybe some of them are open source and some of them are not. But you can use at least one monitoring toolings to check your health of your system. And the last one, but yeah, let's talk about this one. The benefit side of the performance testing. What I said, the continuous performance testing is an automated way of performance testing, which means that you are always ready to run an automation for the performance testing. So which means that it is a continuous testing, and we are running the performance testing in a continuous testing phase, which means that you are getting a lot of benefits for continuous testing and also performance testing. So basically, it returns a quick feedback about the system, which also means that shift left approaches on your system, and it is also giving the current performance of your application, which means that the production on the app on the production is good performing, but you don't know with the new commit if it is still good or not. So within the continuous performance testing, you are just evaluating the current development phase of the performance. So which means that if there is any issues on the current state, then you cannot break anything on the production line. When you are running the continuous performance testing on your pipeline, which means that it is always running and it is always there, for every commit, your developers will get an idea about the current state of the performance. So which creates an awareness of the performance point of your system. Whenever you are as a developer dealing with anything that is impacting, that has some impact on performance, that you will be more focused on the performance side of the feature that you are developing. So it is, I think, one of the great benefits, creating an awareness of your system. And also you are preventing your system by last minute mistake. Maybe you need to create a commit in a minute for a fix, but if there is something wrong or performance, that is not a good idea to release it, right? So also it is a good idea to getting an historical data, which means that whenever your system is behaving good, and maybe sometimes back it turns into a bad, so you are just collecting all the historical data and evaluating your system. So as part of your continuous performance testing as a process, you need to also some time to time checking your metrics in historical metrics if there is anything wrong, because uh, we still need to handle some part of the performance testing is a manual phase, because there is anything wrong, you will catch it again. And yeah, I think that's all that I can talk today. If you have any question, I can answer it now. So looks like we have a question.
We have one question.
Yeah. Yeah, sorry. Shahin is asking a question related to microservice environment and if there are a lot of databases. So within the volume test, we are just testing the databases in terms of if it is handling a lot of when a lot of loads come into your database. So I think the best practice for testing databases for volume testing, especially for the microservice environment, you should you should separate uh, or you should create an different load testing strategies for each databases and for each microservices. I mean, you should for handle each database and microservices within a different type of performance or different how to say um, different performance testing. So you cannot test all the databases at the same time. You need to define some criteria about passing the metrics, and then you can run the performance testing for separately. I don't think that there should be an one run for each databases, because we cannot, maybe we don't know what databases consume what kind of data, and then I don't know what is the dependency between the databases and the microservices. So I think in terms of volume testing, we should always defining a performance testing for each database separately. And yeah, do we have any?
We don't have any other questions right now. I think there won't be any.
Yeah, it's good. It's good to have.
Thank you for the presentation today, Mesut. It was really educational and insightful one. Thank you for being with us today. And if you have any last words before finishing up the session.
Mhm. Yeah, thanks for inviting me for the session. I really enjoyed it. If anything comes up later from the audience, then I can answer it on the one of the platform from the social media. So thanks for joining.
Thank you again, and I hope for the audience it was insightful as well. Then see you in
Mhm.
the next events, and have a nice week.
Thanks.